Allora, buongiorno a tutti. Abbiamo ospite anche oggi, come ieri, Jean-Daniel Nicoud. Ieri ci ha parlato nella sua conferenza del progetto SMACI, di quello che è stato fatto al Politecnico di Losanna, una realtà estremamente interessante e poco conosciuta al di fuori dei confini della Svizzera, un progetto che era nato soprattutto per finalità didattiche. In effetti Jean Daniel si è sempre occupato della parte didattica, il suo interesse, come ci diceva ieri, per i computer e l'informatica nasceva proprio perché, e stiamo parlando ovviamente di tempi non sospetti, aveva visto la reale possibilità di applicazione del personal computer per la didattica che interessava soprattutto i bambini molto piccoli, perché è fondamentale della sua attività, ma un concetto che in molti sottolineano ancora oggi è che questi strumenti didattici sono efficaci se sono applicati ai bambini molto piccoli. Arrivare a insegnare l'informatica o il ragionamento procedurale o la ricerca operativa a studenti universitari, sì, va bene, ma si fa in un altro modo. Un personal computer nelle mani di un bambino piccolo può essere come un Lego, dei mattoncini con cui sviluppare la creatività, l'intelligenza, la capacità di problem solving, di creare qualche cosa che funziona e che dà dei risultati di cui si possono poi verificare gli sviluppi, modificare, quindi uno strumento veramente per l'intelligenza e la creatività. Ecco, sulla base di questi punti, oggi in questa chiacchierata, questa è un'intervista, non una conferenza, quindi Jean Daniel ci racconterà ancora un po' del suo approccio, della sua visione, poi avremo la possibilità di interagire, di fare domande. Io mi limiterò, se posso, a fare da tramite o sottolineare qualche aspetto della sua presentazione, ma ovviamente le domande da parte vostra sono benvenute. L'intervista è comunque registrata e mandata in streaming, ma diciamo, l'interazione è possibile soltanto a chi è ovviamente in questa sala. Bene, penso di non dover dire altro. Jean-Daniel, if you want, the floor is yours for your short presentation, then we may ask question or discuss on whatever you will be showing us. Thank you.
So don't worry. Not on. I start again. Okay, sorry. So don't worry, it will not be a conference, but I wanted to insist of the importance of kids, which we tend to forget a little bit these days. They just have to play with their tablet, and we do not provide them the adequate tools. So what I did, I think the most successful thing I did was that picture. I opened my lab for the kids. This was in 70, and the Wednesday afternoon, kids could come to my lab. It was not specially organized. They had a teletype. They had a Nova mini computers to do basic. Apparently, we started to have a screen and maybe the first Mackies, and they just were happy to come and learn things. And on the picture, I recognized a few heads which became really bright engineers. So that's my point. And I make a big step now because, of course, I found many of these in my courses and as assistant and making the success of Logitech and things like that. So this was the Dauphin I built for the kids especially. So many learn to program with this. You can see in the lab. And I do not, well, maybe I will go back to this. With a vibrating motor, you can do plenty of things, and they still are components easy to get. With solar cell, you can also do plenty of things, and especially in that country where you have more sun than we have. And there's always a problem of connecting wires. And soldering iron is great. I encourage the use of soldering iron, but it's not very good. Well, it's more difficult to implement now. You need to have a workshop, etc. So my trick for establishing communication is to solder magnets at the end of the motors. And then with a magnet, you can connect to a battery, a small battery. If you work with 1 volt, it works. And then you can have the vibrating motor which move over a rail. You know, probably this kind of wooden rails, and decorate, etc. Okay, this is another implementation. With these small motors, which cost nothing, you can also make robots. The problem of the wheels of a robot, it should run slowly, and the motors spin at 6,000 turns per second. Just make the wheel small as possible, so you understand how this robot was working. It was a big success when we had a special day at the EPFL on robotics, several consecutive years. And you can also use the motor to rotate a disc and make some decoration, and either control the motor with a solar cell or with a battery, as I've shown before. Okay, so there's documentation on my website. So, but that just to have idea. I try to have idea and promote them, but the difficulty is to find people who spend time preparing and then asking kids to come. They come very easily, but you have to give your time. So that was my point. It's, I think, a very good investment for the future to help these kids to be aware of what they are doing and try to be creative.
I have a question right now on that point. On the 70s, there was no ready-made electronics or parts that could be used to let small kids experiment and play and so on. So you had to build your own devices that you showed yesterday. Nowadays we've got things like Arduino or things like that. Do you think that this availability of very cheap and powerful mini computers that are the size of a credit card and are very, very cheap could be used not only for controlling automation in the house, but also for let young kids experiment, build, create on their own? What is left? I mean, Arduino is a power platform, but as you have to build on top of that what to do. What is missing according to you?
Well, you saw the Dauphin, the small microprocessor system I built from the very early days. It was a functionality of Arduino now. The problem with Arduino and what all the new simplified computers that are offered is they try too much to show funny functions you cannot understand, instead of trying to make understandable the basics. So with Arduino, you start to understand how to blink a LED, but then you say it's too complicated for you to understand. You load libraries, and there are missing steps to say, okay, stop writing digital write everywhere. Understand that there's a function which is blinking a LED. There's a function which is LED on, LED off. That function is implemented with a facility of the language which is digital write, and you can specify the pair. And Arduino, there's a function in C which is define. It's a dictionary, you see, define, LED on, you have to do this. And I cannot understand why they cut abstraction level, which is very bad. Okay, but beside this, it's a question of education to remove part of the Arduino documentation and rewrite it the way I try to do it. I have a MOOC, massive open-oriented course, which is has been is set of a part of course at the EPFL, and so I try to progress in a better way, understanding C, the Arduino EDA tool, the editor, the compiler, this is perfect. Yes, that's, then too many simplifications, saying, okay, you want to do this project, you take these components, you get picture of these components, no specification, you put these components on a breadboard, and if there's a bug, nothing is explained how to understand how to debug things, and then it works or it doesn't work, and you buy a new gadget, very cheap, and you're very pleased to get cheap product and not to have product. You can spend time understanding them. That's the problem presently.
So it's too complex as a platform, too many layers. You are not down, I mean, to the bare level.
Education, understanding needs an effort. But buying and seeing if something works does not need any effort. So how to make everybody be ready to make effort to have more pleasure, because you get more pleasure when you have spent effort to do something.
Isn't it a sort of paradox that it's now that we have those small platform with a computer power that was unbelievable a few years ago, but they are too complicated to be used, and more, I mean, primitive technologies were easier. Shouldn't it be the opposite? More complex technology shouldn't give us more easy interfaces or so on?
Well, the question is, you have to understand things, and of course you never can understand everything from the bottom up to the level you're interested to reach. So let us try at least to understand the level below. So if you typically with Arduino, if you want to do an application, you should not just load the application, you should understand what is a function, what is an interrupt, why you need interrupt, and sometimes you can just wait for things to be done. And so if you can understand a level below and see, understand the difference between a while and a if, there are some blocking functions, there are some so these are the kind of basic concept which need some time to be understood. Okay, so now you can just be a user and type on keyboards, but this means that you will not participate to the evolution. If something doesn't work, you just say, okay, it doesn't work. and you do not complain, you should do it like this, and it would be more comfortable, smarter. You could add that function, which always have a critical view on our environment, not only to save energy and follow all the keywords of today, but try to always improve and invent our own environment, which is also the environment of the other people.
Okay. Just another question on the technology side, let's say. Nowadays we take it for granted that everybody has a mouse or can connect a mouse to everything. It's the, normal, natural way of interacting with PCs. It wasn't so at your time. Would you please tell us something more about the development of the mouse at the time?
Well,
your interaction with Doug Engelbart, for instance, and so on.
I got the question from a journalist, is there any future in the mouse?
Okay.
And of course, there's no future in the mouse if you not try to do creative work. If you do not try to pass the information in your head through a keyboard and through real communication, not just typing quickly a message on your tablet. So I do not see how you can interact with a PC in an efficient way, making drawing, making text, without a mouse. So now the mouse was really a great invention, and if you were here yesterday, you saw that I visited Doug Engelbart in '71. I make our first prototype of the mouse. It was in '72. Every 2 years, I was asking my technician to develop a new prototype. We added the ball, it was a ping pong ball, to move the sensors. Then we got a steel ball, smaller. And every 2 years, we had a prototype with what to do with them. I had research PhD students trying to find new organization of graphic screen, but we had no easy graphic screen to play with. The processor were not efficient enough to handle bits, dots on the screen. So it's only in the 80s that it started the possibility. And the funny story is my increase of activity on mice was triggered by Niklaus Wirth. You have heard about the Pascal language, he was in Zurich. And Niklaus Wirth spent 1 year as a sabbatical at Xerox lab at Palo Alto. And of course, at Xerox lab, they had a wonderful station, very powerful, and they were using the mouse, which was a mechanical construction with and the point is, the manufacture of that mouse was a small company in California, but that company was not allowed to sell to anybody else than Xerox PARC. So Niklaus Wirth wanted to make a copy of the Xerox PARC system, but he needed a mouse. So of course he knew that I was working on mice. And this triggered me to ask my technician to say, we need a new mouse, make it as best as possible. And he developed the mouse with this round shape. You may have seen, I do not have a picture, but it was a typical shape, very comfortable shape. And so Niklaus Wirth wanted 50 of them. We built 100 of them, and for 1 year, my lab was the only producer of mice. And I got many international interest to say, oh, we have heard that you have a mouse, we need to get one. And I even have visitors from the Bell Lab coming to my mouse and living away with a mouse. And okay, so now clearly Daniel Borel from Logitech knew about this. He was promoting modular software in US, and other projects are purely software projects. Logitech was software oriented. And Daniel Borel understood that there was a future for mice. So he started to mention data head mice, and the problem was I was ready to manufacture mice for researcher and for Niklaus Wirth, but I didn't want it like for the Smacky to go into any production. It was not. So I found a company which was ready to build a mouse, and the company started, and they end up to produce 10,000 mice. And the first one were delivered to Logitech. And the problem of Logitech is these mice was not built in a reliable way. The company has no experience. They wanted to do them by themselves. My technician had to spend a lot of time explaining what to do. I'm not too long?
No, that's perfect. Okay. Go ahead. We enjoy listening to you.
And typically, you see, the ball was the ball was a problem. It was a steel ball, and during the carrying the box to US, the inertia in the trip was destroying the mechanics, and okay, so it was a problem for Daniel Borel to. He decided to start its own production. First with Hermes Precisa, the big calculator company in Yverdon in Switzerland. And then he continued the production, and it's a wonderful story. And so the Swiss company making my round mouse continue because there was such a need of mice for all the graphic station that the market continue, and shipping in Europe was not well. He improved a little bit the construction anyway. What to say? Well, the big success of Logitech was mostly due to two of my kids. And one, René Sommer, wanted from the beginning to put a microcontroller inside a mouse. And this was not so easy by that time. So, and he managed to do it. But in addition to this, he was very concerned about power consumption and nice design, efficient design. So, and it was the best guy to go and talk with all the companies and develop a product which always Logitech was at the top of the innovation for mice, and that's very good for the École Polytechnique because my reputation is only because of this, because of the money Logitech has given to the school. But we made very interesting projects related to the mouse, but continue with your question.
No, it's okay. As I said, we are enjoying listening to you because some of those aspects are obviously not publicly known or just have not been told since then. So it's interesting to understand relationships among different people or companies that helped shape our life like it is now. as I said, nowadays we take it for granted to grab a mouse and do things. Until a few years ago, I mean, the first large-scale commercial computer that used the mouse was the Apple Macintosh. It was 1984, and
yes.
all the world was absolutely shocked by this new device that nobody has seen before. It was known in research labs and so on, but the man in the street didn't knew of that, so it was a real revolution. It took some 12 or 14 years, maybe 15, from the initial concept of Doug Engelbart to the
in 65.
20 years, almost 20 years.
Yes,
so
that's
it's been a very long story for a easy and natural device as we see together. So it's interesting to see how this got shaped in time, and many people that helped create the final concept and companies. But I have
the robot was really admirable because he was working with big computers, and I've heard that the interface for the mouse had costed $100,000 because it was very complicated to bring real time inside one of these big computers.
Yeah.
And so then later my problem was to have the graphic screen. The interface was easy with the mini computers, but the plasma display were too expensive and they disappeared.
Yeah.
And we needed time to have the chip to make a video stream.
Because of course, if you do not have a graphic screen, the mouse is useless.
Yes.
You can't use a mouse for typing. So both the technologies have to be, mature at the same time for them to be usable. Okay, I have another small question. In the same period of time in Zurich, you already mentioned Professor Niklaus Wirth, did something very important for the evolution of the informatics. He invented, or at least defined, the formal concept of structured programming with a very famous book that we all know. So it changed the way programs were written. Before Wirth, programming was more an art than a science. Then with the work of Professor Wirth and others, of course, but he was the most famous at the time, programming became more a science than an art. So you mentioned that some relationships among your work and Wirth and so took place in the time. Could you tell us a little more how, if those views of Wirth influenced, for instance, the design of the software for the SMACI or the operating system, or not?
Okay, so it's important to understand that in the 1980, when Wirth came to visit me, there was two trends, and unhappily, these two trends didn't work together. And sometimes I say, I've been stupid. I should have spent few months with Niklaus Wirth to better understand what he was trying to do, and maybe influence, because what happened is I was trying to do my best with a small chip with 64 pins, and he was copying a machine which was very complex with big boards, with a lot of memory, and he spent 5 years trying to do a product with this. And of course that product was too expensive. It could have it was very, very, very powerful, very nice to use. He had wonderful programs to interact with, but the machine was a flop, well, partly because the guy in charge of making it as a product was working in US, didn't things make, well, they invested too much money in the bad direction, and during that time, the microprocessor was doing its way. I spent a sabbatical in '94 at Sun Microsystem and Stanford University. I visited Sun Microsystem because I was concerned about the 68000. And I visited Sun, they were 12 employees. I started, they were 50. I left three months later, they were 200. So the future for that direction. And so it's a bad thing for Niklaus, because of course the modular language didn't come in this machine. It would have been much better than the C, which I like very much because it's very close from the machine. Yep. But modular allowed to make things in a much better way, and it's a good compromise with C++, which had all the tricks and C.
For a certain moment, there was the possibility that an operating system based on Pascal was being marketed on a mass scale, because it was one of the products in competition to be the operating system for the IBM PC, the USCD Pascal environment. Then it failed, and of course MS-DOS took place, and we all know what happened before. Have you ever wondered or thought why it wasn't accepted, and what could have been the world of information technology if a Pascal-based environment would have taken place instead of all-minded MS-DOS and whatever it went later?
Well, of course, I got collaboration with Zurich, and they got SMACI to implement modular on the SMACI. We had Pascal on the SMACI. The people we were interacting with, the teachers, they made nice application with BASIC. It was perfectly the good tool to present and master and do educational application. I do not remember, I was not following this closely, the complex projects. They've been done in Pascal and not in modular on the SMACI.
Okay.
But C was everybody switched from assembler to C to build the real application or the useful program for text editing and comptabilité.
Sì, contabilità. Okay, accounting. Accounting.
Well, handling of the money of a company.
Accounting, contabilità.
It's now the success. Epsitech, who was building machine, went to the software by providing this service for company to handle their pay list, and now they are very successful with the same people. That's the same team. They are growing up, but with the same person are there to to continue the company.
I would like you to put again the picture of the kids in your lab, which is really inspiring.
The very first picture, I don't know.
Yeah, that black and white picture of kids in your
with
lab.
the kids.
Yeah, it is
Yes,
beautiful,
yes,
inspiring.
really,
It was 1971. You mentioned.
It was in 70. You can see the. Well, there's a.
Yeah, they've got
A
teletypes.
printer which was not interface. Maybe we'll consider to do an interface with a typewriting machine. I don't look at it. You have a telex someplace.
No screens, of course, so that weren't available.
You can see a screen.
Okay.
The kind of you see the place to put things were planned to have screens and. No, it's.
So, if it was possible to interest kids and to let them play with those ugly and complicated computers at the time, why aren't we doing, wonderful things nowadays that we got lot of much powerful machines? It is not, I guess, a problem of machine themselves, but the way of thinking the education, or not?
Well, it was a time where these kids, I found them because there were electronic clubs, and it was very successful by that time. And the good point also is the company concerned with electronic and the development of this technology made a group. One of my student friends influenced this to have this company being a group of company, and they decided to promote the understanding of electronic. So I had started some activity and I was encouraged to make it at a larger scale, and I got money from the company to give material and places to work to kids. Okay, so and what I was especially lucky was to find one of these young kids who wrote a journal, and there were 100 of this journal, very thick, 20 pages, every 2 months or 1 month. So passing the information, you can build this kit, you can have the news about the Dauphin I've built, all the documentation was there, etc. So that dynamic, I can rebuild it. I do not see,
We've got the internet nowadays, email, much more possibility to get in touch with clubs, with people, and so on.
Well, I think it's the responsibility of everybody to say, what can I do? Because it depends on the environment. It depends on your friends. You must not be alone.
Yeah.
You must find a place. It may be very difficult to find a place where you can meet and organize your workshops. Or it can be very easy. But you have to spend your time and believe. And okay, I know places where it works very well, and I know about many experiences with went short very quickly.
Mm-hmm. Okay, thank you. I think I've done enough questions to Professor Nicoud. Se ci sono domande a questo punto, cioè penso di averne fatte pure troppe di domande io, quindi se ci sono domande dal pubblico è assolutamente disponibile a rispondere. I temi, quelli che abbiamo trattato oggi o ieri per chi c'era, ma fondamentalmente appunto la didattica con l'informatica, per l'informatica, noi bambini molto piccoli, e insomma l'interazione con le macchine. Qualcuno vuole fare qualche domanda? Ok. Sì, vai. E lo puoi fare in italiano e la traducono loro in inglese.
Piacere sentirvi e incontrarvi. Lei ha mai conosciuto il professor Skinner, che negli anni 60, lui era un behaviorista, uno psicologo behaviorista che riuscì tramite computer a fare parecchie lezioni anche universitarie appunto in autonomia, nel senso che i ragazzi potevano mettersi lì al terminale e fare dei problemi, delle cose così. E questo era proprio a metà degli anni 60, da una ricerca che ho fatto e anche da... Grazie.
Yes, yes. Okay, interesting. When I mentioned that I started to teach in the college, and I was very concerned about using computers and teaching machine. It was the time of the teaching machine with multiple choices, and I built one mechanically for my kids. And then I even had one of the kids in my college who played with Fortran and tried to make one of these multi-choice programs. But of course it was too primitive, and I showed the screen, the plasma screen of the Plateau project. It was of course a fascinating project. Okay, but the technology was not ready for this. And we can talk together summer of another project. I was believing it, and I put a research student on it. But
Professor Nicoud, quando è stato terminato il Plateau Project? Quanti anni è durato?
I have the feeling that in 72, 73,
It was over.
It was closed, yes. It started too early, it was wonderful, but too much only a research project.
Thank you. Qualche altra domanda? Qualcosa di interessa? Direi che, esatto, il tempo è volato. Jean-Daniel Nicoud, thank you very much for your presence, for your patience, for your wonderful stories, and all the best for your activity. Thank you very much.
Okay.